In this video, I'm going to go through the process of downloading your own vector map file from the internet of the United Kingdom, but it's also useful to know where you can download a political map of a country, because the location of the website allows you to download just about for any country, which could be useful for other work that you do. Then I'm going to show you how to prepare your data in Microsoft Excel and export it in a format that's going to be useful for the QGIS GIS package to be able to import. Then we're going to move on to how you load QGIS, how you import your data and display it on a map of the UK. And then finally, I'm going to show you how to create the inverse distance weighted choropleth layer and generate a proper final map complete with a scale bar, a north orientation arrow, a title and a legend, and how you can then export that map as either a high resolution PDF or put it into Microsoft Word by exporting it as a high resolution image. So scientists will often make observations of phenomena at different locations, and this could be of anything, depending on whether you're a chemist or a biologist or a geographer. It can be air pollution, temperature, number of insect or plant species. And scientists will often take these measurements based on a field methodology. So it could be a regular grid pattern, or it could be random locations. Now, if you have sufficient points and they're reasonably well dispersed across an area, then you can use a method called interpolation to fill in the gaps between the known points that you have sampled, and then create a final gridded raster layer where the process will fill in the gaps. So a suitable color ramp can be used to allow the viewer who's looking at your map to interpret it, and more importantly interpret the underlying spatial patterns. So you can have, for example, with air pollution, values that are high can be red, and values that are quite low, denoting clean air, can be blue or green. And that's, for most of us, a kind of an obvious choice of colours to use to represent danger or lack of danger, or high values and low values. And the example I'm going to show you is using inverse distance weighting, or IDW. And this will take a look at the points that are known, that you have sampled, or that you have secondary data where somebody has sampled, and it will assign values to the gaps in between, which are the unknown points. And it does this by calculating a weighted average based on those known sampled points. The method uses the inverse of the distance to calculate each known point when it's calculating the weights, hence the term inverse distance weighting. So the video will now follow and take you through the entire process using the free open source software known as QGIS, which you can download for Windows or Macintosh or Linux. In this brief video, I'm going to show you how to download a shapefile, which is a vector map file for any country in the world, and we're going to choose the United Kingdom. And you just need to go to Google and type in two words, DIVA space GIS, Diva GIS, and hit the enter key. It's the first thing that comes up in the results, and you'll notice that Diva, by the way, is a free GIS package, but there are some subsections on the website, and what we want is the free spatial data. So we click on free spatial data, and there's actually a number of different data sets here that you can download. But what we're interested in is the country level at the top. So click on country level data, and you can select just about any country in the world. We want the United Kingdom though, so we're going to go down to U and United Kingdom, and these are the available data sets. Remember, these are vector map data. We just want an outline map of the UK, so we're going to leave it as administrative areas and then click on OK. This will generate a zip file once we click on download. I'm going to save that to the desktop. Okay, this is the resulting zip file that I just downloaded from the Diva GIS website, and it's a zip file, so it's compressed. So to uncompress it, you can't use it until you've uncompressed it. I click on it with the right hand mouse button and select extract all. This will then by default extract it to the location of the zip file, which in this case is the desktop. So I'll just click on extract, and here we can see that we've actually got a number of files inside this zip file. You need to keep all of these, but the one that we're actually interested in is this one, and this has a .shp file extension. There's an ADM2, an ADM1 and an ADM0. The difference between them is the level of detail, the country outline and the internal sub-political regions of the country. And so we're going to use the ADM1 file, but just keep all of these together, and it might be useful once you've downloaded to back this up, because you might need it again in the future. Now the data for this practical is contained in a comma delimited file. What do I mean by comma delimited? Well, the three columns that you can see here are separated by a comma when it's exported, when you look at it in a text file. Now you don't see the commas when it's in Excel, because Excel is smart enough to actually import it as an Excel file. But when you look at this raw data in something like Notepad, you would see the values in each column separated by a comma. And that's why it's got a .csv file extension. CSV stands for comma separated values. And you'll notice that there are three columns, X, Y and Z. The X column corresponds to longitude. So this is degrees longitude. So this is the east and west component of our locations. The Y is the latitude, and that's the north-south component. So degrees latitude is north and south. That tells the GIS the location, but the underlying data, the actual air pollution data, is contained in the third column. And the third column is the Z column. So it goes X, Y, Z. And the Z column contains data that was actually collected by students that had Petri dishes outside their house where they live by the roadside. And so all of the particulates in the air, the impurities, would settle in the Petri dish, and it would be examined using a microscope, and the relative number of particles in a square millimeter would be calculated. And so you can see here that the data file is already sorted according to the Z. So there's a location here with a longitude of -2 point something and a latitude of 53 point something, where the air was very clean. There were only 2 particles. And then at the bottom of the file, when we scroll down, at this location there was a huge number of particles, over 1,600, about 1,600 particles, which is very dirty air. There's a lot of particulates. So it could have been that the student who lived at that location lives by a busy road junction with a lot of lorries and cars passing by. One of the things you'll need to know later is the minimum and maximum values for the X and the Y, the latitude and longitude. And there's a very easy way of doing that with Excel. So if you highlight all of the data and you go up here to data and sort, you can sort by the X or the Y or the Z. Well, the X, of course, is the longitude. So if we select that, and it's going to be smallest to largest, click on OK. So now we can see on the X that the smallest value is -3.01691. So that minimum X is going to be important later, so you need to write that down. And the biggest value is minus 1.2873. So that's going to be important as well. Now we can do the same thing for the Y. We can just highlight it again, go to sort, and this time we sort it by Y, which is the latitude. And again, we get our smallest value, 53.10027, and the largest value is 53.73538. So those four numbers, the minimum and maximum X and Y, you need to make a note of that because the GIS package will need that later. So that's what your data should always look like when you import it, so that you can import it later. And if you don't already have a CSV file, you've got an Excel spreadsheet and you've created your 3 columns, it's important to go File, Save As, and select the CSV, delimited option, and then click on Save. Now this already is in CSV format, so I don't need to do that, but if you had data that was just in a raw spreadsheet file, you would need to make sure you exported it with that particular option from all of these different options it makes available. So the next thing we're going to do is actually open QGIS and import this data. To load QGIS, just go to the Start button, navigate to the group for QGIS, so it'll begin with the letter Q. And what we want is QGIS Desktop. The number might be different because you might have a different version of QGIS, but you want the QGIS Desktop option, and just click on that and the program will load. Okay, so once QGIS is up and running, the first thing that we want to do is to bring in our map of the United Kingdom. So here on the left hand side where it says Open Data Source Manager, we click on that icon and it's a vector file. All map files are. So we'll select vector from the list, and where it says source vector dataset, we just click on the button and we're going to navigate to the desktop and the location of the unzipped file folder, and we want the SHP file extension, which is always going to be the largest of the files, and we'll choose the ADM1, which is sort of intermediate level of detail for the United Kingdom, and select open and add, and then just close that box. So now we have a map of the United Kingdom. Now the problem is it's by default it's coloured in, and in this example it's green, but it can be a random colour, and I'd rather that was just an outline map of the coastline. So what I'm going to do here on the left hand side under layers is double click the GBR ADM1 and go to this symbology tab and click where it says simple fill, and where it says fill style, change that from solid to no brush. Click on apply and OK. So now we've got a map of the United Kingdom and it's just an outline map. Now the next thing we're going to do is import our data. This is the actual data in a .csv file, and so what we're going to do is determine what type of map projection this underlying shapefile has, because we need to match the same map projection with the data that we're going to import. So we double click on the GBR ADM in the layers panel again. This time we just go to information, and what we can actually see here is that it's EPSG 4326, and that's basically what we call WGS 84, which is a very common type of global projection. And so we need to remember to write down EPSG 4326. That's going to be important in a few minutes time. Okay, so what we're going to do now is import our CSV file. So I'm going to go back to Open Data Source Manager, click on Delimited Text. Now this is a CSV file, So we need to tell it the name of the file name. So we're going to click on this button and we're going to select from the desktop number of particles at road.csv and open. And you can see it's got the 3 columns here. There are other options, so you can leave it ticked where it says first record has field names, because they are. These are labels X, Y, and Z. The geometry is where we have to tell it the map projection. So at the moment it says invalid projection, so we click on this button and it was 4326, and this is the WGS 84 4326. So we just typed it in the filter box and it's the option that comes up here at the bottom, and we click on OK. So now we can add this and click on close. And if I zoom in to the northwest of England, you can see each of these dots is actually a data source. It's where the number of particles in the atmosphere that was collected in a Petri dish has actually been sampled. Right, so the next step is to take those underlying sample points and convert them into a smooth gridded surface, what we call a choropleth layer. And we're going to use a tool called inverse distance weighting, or IDW. So we need to go up to the processing menu bar and select toolbox. And on the right hand side are all the different tools available. You just type in IDW, and under interpolation we've got IDW interpolation. Just double click. Now it needs to know, well, which vector layer contains the data. Well, that's the number of particles at road, so we need to change that to number of particles at road. Now if you recall, there were 3 columns in that spreadsheet file, X, Y, and Z, and it was the Z that contained the actual pollution data, so we need to select where it says interpolation attribute, we change that to Z, and we click on the plus button, and that tells QGIS that the interpolation should be performed on the Z column, on the data contained in the spreadsheet file. The last thing to add is the spatial extent of our underlying points. There's no point in going beyond those sampling points because there's nothing there. So we need to constrain the analysis to the upper and lower latitudes and the easternmost and westernmost longitudes. So it's asking for Xmin, Xmax, Ymin and Ymax. X, of course, is the longitude and the Y is the latitude. So minimum X is in fact the longitude, which is going to be the smallest number of the 2 longitude values, and they're both negative, so it's the one that's most negative, which is -3.01691, then a comma and a space, and it wants to know the maximum of the 2 longitude values. This is -1.2873. Then a comma and a space again, and it wants to know what the minimum latitude is, the Ymin, and that is 53.10027, comma and a space, and then the maximum latitude, Ymax, is 53.73538. So everything is now ready to create our interpolated layer, so we just click on the Run in Background button and then close. Now this is the layer that's created. It doesn't look very good, it doesn't look very pleasing because it's used different levels of grey, and so I'm going to change that to different colour levels. So where it says interpolated here in the layers panel, I'm going to double click, and in the style tab I'm going to change the single band grey to single band pseudo colour. And it's changed it using, there are different colour ramps here. This is the spectral colour ramp. Now it's not very intuitive because the low values are red and the high values are blue. I'd like to reverse that, and that's easy to do. You just go back to colour ramp and you select invert colour ramp. Now the low values are in blue and the high values, high pollution values, are in red. So you just click on apply and OK. So what this is showing us using different colours is the different levels of air pollution. And right here in the middle is Greater Manchester. So these values off to the west, there are some high values. You'll notice some red blobs and orange blobs, and those actually correspond to the motorway network. So there's quite a lot of traffic goes into Manchester every day and then in the evening exits Manchester from the west. So you've got the M62 motorway linking Manchester to Merseyside, and we've also got the M61 orbital going around Greater Manchester, and so it's likely that those locations correspond to the different motorway networks. Now what I'd like to do is actually create a really nice cartographic map, and before I do that I'm actually going to rename some of these layers, and also the number of particles, the sampling points, is actually underneath the brand new choropleth layer, so you can't actually see them. So I'm just going to drag and drop that to the top, and we can actually now see the individual sampling points. Now what I'd like to do, because they're a little bit big and they tend to obscure the data underneath, I'm just going to change the symbol. So I'm going to double click where it says num particles at road, and we've got some different options here. I'm actually going to choose this one and click on apply and OK. So that actually is also a little bit big, so I'll just change the size of that. The size is 3.2 at the moment, so I'm going to reduce that to probably 1 and then see what that looks like. That's fine. So I can actually see the colours now of the choropleth layer, but it's easy to see the individual sampling points as well. Now the last thing to do before you create your map is to change the name of the separate layers in the layers panel. So this number of particles at road, these are actually the sampling points. So I'm going to right click and select rename, and I'm going to type in sampling points. The interpolated layer is actually the different colours represent different levels of air pollution. So I'm going to rename that air pollution particles. So that's the number of particles measured in a Petri dish. And then the GBR ADM1 I'm going to rename UK map. Okay, so now we're ready to create our nice high quality cartographic map. So go to project and we select new print layout, and it wants a name, so I'll just call this air pollution map. Okay, so what we have here is what we call a map canvas. So this essentially is our sheet of A4 paper, and we can add the various map elements. So we do this by working our way down through the add item menu option. So the first thing, of course, is to add the map itself. So when I select add map, nothing happens, but the mouse cursor has changed into a crosshair. And that's because QGIS is waiting for me to draw a rectangle, and that rectangle is where the map's going to be placed. So I'm going to start not right at the top, because I want to put a title along the top. So I'm going to leave room for the title near the left-hand edge of the paper. I'm going to drag and release about here, because I want room on the right-hand side for the north arrow and the legend, and I need room below to put the scale bar. So when I let go, this is basically, it just takes the map that we were working on before. Now I can select the map and deselect it by clicking on it and clicking off the map area, and I think it'd be neater if it actually had a box around it. So I've selected it. It goes to item properties on the right. If I scroll down, it's got frame, and the frame I'm going to select, and I think we can just leave it as the default there, and you can see it's actually drawn a rectangle around the map. If we wanted to, like most of these map elements, has a number of options. I could have changed the color to a different color, but I'm just going to leave that as it is, as sort of dark charcoal grey. What's next? The next thing is a label, and that's basically text. So we're going to add a title, and I'll click roughly here at the top where I want it to go. Now it's got some placeholder text, so I need to change that on the right hand side, and I'm going to put air pollution, particles measured by students. Now that text isn't very big at the moment, so what I need to do is actually change the size of that text. So I'm going to go to font, configure formats. I'm going to change that to 20 size. That's better. And I'm going to change the color. I think I'll change it to a kind of dark blue. Now you'll notice there's a big box here that contains the text, so I'm just going to make it a bit neater by making this smaller, moving out of the way. So that's our main title along the top. Now every map should also contain the name of the person who created it, so I'm going to add another label, but here on the bottom left I'm going to put my name, because I'm creating this map. So I'm going to put map created by Mark Cresswell, and I'll leave that as the size it is because it's just going to be here on the bottom left, but I will make this ridiculously large rectangle a little bit smaller just so it doesn't interfere with anything. Okay, so the next thing I need to add is a legend. So the legend, when you click, it's again waiting for you to tell it where you want the legend to be placed. So it's here on the right hand side, so I just click on OK, and that's the legend. I'm just going to move that up so it's in line with the top of this map rectangle. So that looks nice and neat. And the next thing I'm going to add is a north arrow. So go to add arrow, and I'm just going to click and then move it up, and then right click, whoops, try that again, left click and right click. And I need to put the word north, so I'm going to go back to label and type the word north. Every map should have a north orientation arrow, and make this fit the size of the text and move the text so it's just below the north arrow. There we go. And the final thing to add is the scale bar. So I'm going to go to add item, add scale bar. That'll go below the map here, and again just bring that rectangle in and move it so that it's just in line with the right hand edge of the rectangle. And that's it. That's my map. And you can see it's got a title, it's got who created it, it's got a scale bar, a north orientation arrow, and it has a legend showing me the symbol used for the sampling points, the outline of the UK map, the coastline, and more importantly, the colours denoting the different air pollution levels. So once you're happy, and you can experiment of course with different colours and different styles, but when you're happy with the way it looks, you can export this. So you can go to layout. Now you can export it as an image. If you want to put that image into Microsoft Word for an assignment, I would recommend that when you select export as image, that you select PNG format. PNG will be much higher resolution. Alternatively, if you just want a single map as a document, you can export this to a PDF file, and that will create a very high resolution PDF file for you. So this has taken you through all the steps from importing the raw data from a spreadsheet file, downloading and importing a map of the UK, and producing a final inverse distance weighting choropleth layer where the different colours denote the different levels of air pollution. And so you should have a go at producing your own maps using data that you've downloaded from any website, or even data that you've created just to actually try out the technique.